Thank you, Dr. Raghavan. I hope you can hear me. All right. I want to say two things. I mean, one is a program on AI for science and engineering, which is currently open for proposals. Our goal, often we speak of missing many buses and trains and other things. Okay, so let's hope we don't miss this bus of AI for science and engineering, which is to transform how we do science and engineering using AI, and also collaboration between practitioners of AI as well as practitioners of science. So it's indeed an honor for me to be here amongst all the fellows of Indian Academy of Sciences, a very, very prestigious institution that's been with us for since 1934. So without further ado, those are the two messages. One is, I will talk from my own experience about how AI is transforming the sciences and engineering, but also, I think we got to also get on with it and be part of the change as well as, make change happen. So we have a program for that. In fact, the good news is just yesterday we announced a 1-week program. It was closing next week, but it's going to be one more week. So if please get your proposals ready and submit. We fund up to 30 crores per project of this, but these are expected to be consortium projects and so on, focused on AI for science and engineering. So without further ado, and this is my QR code for my LinkedIn, if you'd like to connect with me. And we are quite active on social media, so one message from ANRF I'll ask you is, please connect with the Anusandhan National Research Foundation on any form of social media, whether it's on Instagram or other things. The only thing we're not on is WhatsApp. And Aratai, we will correct that as well. So we'll be soon on WhatsApp and Aratai very shortly as well. Okay, with that, just a couple of words about ANRF for folks who may not understand what we are up to. So ANRF is a mechanism that the government of India has to do far better in and funding science and funding research and innovation in India. So we have two types of things that we do. One is grants, which is in the early TRLs 1 to 6, which we call the ANRF core mission, and then there is from TRL 4 and above. We have a separate scheme called RDI, which has been announced about a week back by the Honorable Prime Minister, and that's the 1 lakh crore corpus or a fund that is only for private sector, but academia can connect to private sector in interesting ways, behind the scenes, etc. So I think, but that is not a grant. It is only patient capital, things like loans and equity and so on. And there, government is not a capital allocator. We actually appoint second-level fund managers who, in turn, further onward invest into companies, startup companies, and others. So I think this is a dual engine approach. I know that in Andhra Pradesh, Nara Lokesh says dual engine bullet train is a new term I heard recently. So so think of this as dual engines. Okay, whether it's a bullet train or not, we'll find out shortly. Okay, so grants, non-grants, academia and research institutions. But our overall goal is we want to increase the aggregate amount of research spending in the country, but also to catalyze more non-governmental research spending in addition to the incremental government spending that ANRF puts in, plus increase the productivity and impact of our research, right? So these are the sort of multiple objectives that ANRF has. So we have, in our grant side, we have more horizontal in nature, similar to National Science Foundation. Our erstwhile organization called SCRB has been dissolved, and some of the programs have been relaunched in this area. So those are meant for fundamental research. Often I'm asked whether ANRF will continue to support basic research, and the answer is very simple. Without science, there is no engineering. Without engineering, there's no technology. Without deep science, there's no deep tech. So therefore, we must support basic sciences and fundamental sciences, and we'll be increasing the investments, and we are increasing the investments in basic sciences. Okay, how we do that, and can we do more? Can we do different things? These are all points of debate. I welcome that debate, and we will continue to be working with various parts of the scientific ecosystem to do that. So, then the vertical part of our mission is where we are doing more mission. So almost every month I'm launching a new mission mode program. In fact, AI for science and engineering is mission mode program where we are investing of the order of 1,000 crores just for research and engineering in this area, just to help catalyze the intersection between science, engineering, and AI. So if you put it in a different way, you can think of all our horizontal programs as a foundation, our vertical programs as pillars. We have three major goals in our pillars or vertical focus. So one is the pair or other class of programs where we are aiming to uplift and broaden the distribution of excellence across our institutions beyond the narrow sliver that exists today. So the pair program is an example from that vintage. The mission mode program, AI for Science and Engineering, is an example from that vintage. And then there are other programs we are making to drive a lot more industry academic collaboration, a lot more translation, and so on. The idea of translation and so on will be embedded in many of our mission mode approaches as well. But we see the need for a lot more translational facilities and so on that has been lying out. So we are going to do something special in those areas as well. Right? And overall, ANRF as an apex organization at the top, we will be doing other things which we think are of importance to lower the frictions across the various, we'll be sharing a lot more information, data repositories, things of that nature, open data platforms. And right now we are working on our national dashboard of all research and innovation across India, etc. Okay, so these are few things that we'll do. I come from private sector is focus. I'd rather do a few things really well rather than doing many things badly. So India has a habit of doing many things badly. I'd rather do a few things, and I hope we'll do it well. And as part of our broad-based programs, we will deepen our investments and try to incorporate some of the key pieces that are needed. Right? Over time, we hopefully will do more things well. So on the vertical programs, I mentioned AI for Science and Engineering. It is one pillar, as you can see there. There are many other programs we are launching as part of this vertical ideas. We have currently a program ongoing in electric mobility where it's already selection have been done. Currently projects are already off. In fact, I'm going right now to another, after this meeting I have to go there in another place where to review one of these things. So we are going to be upping our governance standards of running these programs much better. For too long we have many of these large amounts of money that have been given in fund and forget model. So I keep joking that I will not forget. Okay, so we will not fund and forget, especially for our bigger programs. So but at the same time, our goal is not just to sit around and boss around and so on. Our goal is to mentor and be helpful to find how we can reduce the frictions, how we can help the journey towards success, even though the success might look differently from what was originally envisaged. But as long as the process is there and we are going in the right direction. So our principles will be of monitoring, mentoring, and ecosystem linkages and support for translation and success. Because end of the day, if deep science remains deep science, you don't get the impact to society, and so that translation is as important as the deep science as well. So we hope to be helpful in that process through the better governance and things that we can learn from the best of other places that we've had exposure to. So be doing something special for societal challenges in India. Since there are many societal challenges, I'm still thinking through, and our Executive Council has yet to approve these programs. Rather than running each one separately as a vertical, we could pick up a few verticals where I get more interest from our ministries, but others I might do a broad-based societal innovations type program. We are thinking about a broad-based translational program as well. So I keep joking that I come from Bangalore, so we have a Rameshwaram cafe which dishes out dosas very rapidly. So we are dishing out programs like dosas, so there should be no shortage of funding. So somebody actually commented to me, I'm giving too much funding. I don't know who it was there, Nilesh. Okay, so anyway, but we have to be careful, and we have to be mindful of how we select and keep up our standards of selection, I think, and raise that to gold standard. But Nilesh is one of the outliers. I think mostly I get people saying I select less and I need to increase my funding. So we'll be doing more as well. Okay. So the other thing is that many of our programs tends to be vertical programs tend to be more interdisciplinary in nature, which sort of are falling between the cracks. If you notice, they are also aligned towards either economic value chains we want to create or societal problems that we may want to consider solving. So this would be the nature of our vertical approaches. But on the horizontal, more fundamental or baseline and broad-based things, we hopefully will do more as well. And of course, I'm picking one by one what to go after. Okay. Another thing we are doing is bringing our science and engineering to the world of social media. So social media has been used for all kinds of weird stuff, but I'm interested in social media being used as a first-class medium for scientific and technical dissemination, not just a marketing medium or a PR medium. So to support this, since I come from the world of AI, there are now, it is now possible, Google had released something called Notebook LM, so we got inspired by that, and we are developing a platform called Saral AI, which I've been encouraging and nudging and soon requiring more people to use. So the idea is that scientists are great at and researchers are great at writing papers, but they're terrible at social media. So we want to give a single button, just like an Amazon one-click button. So you take your papers and it will convert it to all forms of social media. So like it will convert into a YouTube video. It'll take your paper, convert into a YouTube talk. It'll convert into a Twitter post. It'll convert into a LinkedIn post. It'll convert into a Instagram reel. All of these sorts of things, right? So but it's and also we are supporting as of now we have integrated with Bhashini, and we support 19 different languages. So somebody can read your paper in a demystified form in Assamese, right, or in Punjabi, or in Gujarati, whatever, right, to their own local language, or here in Telugu, right? And also, we are working with both some of our India AI awardees like Sarvam AI, and we are working with Bharatjan, we are working with Bhashini. So we are bringing the best of AI. Now, this is an example of applied AI, right? So we are trying to use this to help democratize, research and innovation. We think this is very much more important than it seems, because knowledge diffusion from basic science to impact, is very important. And we think we can help accelerate that through a combination of tools and nudges, encouragement, requirements, and so on. Okay. So coming to my talk here, AI is a new frontier for science and engineering. Of course, all of us or many of us have used ChatGPT. You can ask it interesting questions, you get answers, you have a more conversational form of interacting with things. Knowledge discovery, knowledge, ideas are very interesting. But what is I mentioned briefly about knowledge diffusion. But if you think of the discovery of science as a knowledge problem, how do I discover new scientific things? Or once I have some science, how do I move from deep science to deep tech? How do I go in that journey, right? And scientific data is also very, you have microscopy data, you have characterization data, you have all kinds of data, which is a combination of different modes. You have time series, you have point clouds, you have sort of medical imaging data sets. So it has a lot of interesting things of that nature. But what's also interesting more recently is that just like you have numerical approximations for PDEs and so on, you now have AI approximations. So in other words, you can take a partial differential equation and directly model it in AI as a neural network, and you can train up a neural network, specific types of neural networks. These are classes called neural operators and so on. Similarly, the same techniques that have been used for ChatGPT and the other variety of things like DALI and so on, things like whether it's transformer-based modeling or diffusion models, they have started to become interesting because you can now model molecular simulations through that, or biological simulations through that, and so on. So for different classes, different tools are emerging, and India should not sit back and wait for the globe to invent and discover this. Why can't we develop stuff? That's why I'm offering lots of money. So to please submit. So we want to be a catalyst to help you get on with it and both adopt science, AI in your science, as well as to. Fundamentally, we believe that there is a potential. Again, it has to be realized that there's a potential for rapid acceleration, whether in the discovery process, in the experimentation process, in the in the conversion process, or what we call the translation process, right, and so on, right. So exactly how that is going to happen, the world is yet to discover. So I think that's the exciting part that's out there. So there are several sorts of ideas that are out there that are emerging, whether it is to directly model science and engineering, and there have been recent Nobel Prizes around it, as Dr. Raghavan mentioned. So then there are analogs and things of virtual worlds that one can create. How AI can get used in experiment design and doing sort of virtual experiments and virtual testing, and of course various other things. At the same time, the hyperscalers have been putting out lots of open models that are out there, so that it gives a great starting point which can be further customized and so on. And as part of our AI for Science and Engineering, we'll be hosting all of these models, so you don't have to start from scratch as well. So you can host and fine-tune any of the interesting global models, whether it's for atmospheric modeling or whether it's for biological modeling and so on. Of course, you can develop something from scratch with your own data sets as well. Okay, and the importance of data sets and good. So either you have to have some sort of federated way of aggregating them and sharing them, or ANRF will be also doing other things to help share data sets. And wherever we funded national facilities, we'd be requesting them to sort of put up data sets in a way that it can be shared across all of research community in India. Okay, so now exactly what it means for your specific area is yet to be discovered or right. There are many tools coming out, and let's look at it. And the other interesting thing that is happening is that AI is also approximating, say, numerical simulations, and those AI surrogate simulations, might be slightly, erroneous, but let's say they have some 5% error, but they are blazingly fast. Okay, so which means that by the time you do a fine-grained FEM mesh simulation once, you can do 1 million AI simulations, right? Once you do that, there is an interesting aspect that happens, which means that you can start doing physics-inspired modeling or physical modeling. Your science can be directly modeled. See, today a lot of the digital twins are only used in the design phase, but for example, when a wind turbine is actually operating, why can't you have a full-fledged AI model that actually runs and models the physics and so on, both of the fluid flow as well as the the design system, etc., and then optimize it, right? So the opportunities in sort of the full end-to-end spectrum is there to be realized. From an entrepreneurial side, things like CAD and all the computer-aided design, computer-aided manufacturing, the entire area of high-performance computing, all of these are going to get completely rethought. And there is a new opportunity for startups, Indian startups, etc., to come up in these spaces, and we be driven and accelerated through an open ecosystem. Therefore, one of the things we have done in our program is that we've said that you can get my grants, but whatever you do, you have to put out your data in the open. Okay, if your goal is open data, if your goal is open models, you have to put out your model in the open as well. So with an MIT permissive license, which we call an ANRF open license. So this we hope to drive faster translation and ecosystem development, where our startups coming out of, say, academia and quickly pivoting over can drive, or collaboration of existing startups with academia can happen much faster. So therefore, we can think of this as like a new India stack that can develop, with our models being adopted by the world. Okay, so that's the broad thinking. Therefore, we are thinking of this as combinatorial innovation, just like we have a combinatorial space that we want to expand. You have individual models as Lego blocks. They have good descriptions, but now there is already technology, and I was working on some of this in Microsoft before I left, where you can automatically, AI can actually synthesize an agent or a workflow across millions of models for which model descriptions are available, or model cards are available. So just having, just enabling a large suite of open models, which India is good at in quantities, can enable a future of AI agents, scientific AI agents, which can do amazing things. Okay, some things which we may not have imagined, or very hard for us to imagine today. Okay, so that's the broad thinking. So this is the program. So the approach we're taking is a programs track, which itself has 4 sub-programs or 4 programs. One is AI for Science and Science of AI. It's sort of like a catch-all for whatever is not there elsewhere. Then there's AI for Engineering, specifically engineering design, computational fluid dynamics, and accelerated materials development. I have partnered with DRDO there because they were interested specifically in advanced materials development and fluid dynamics for the naval things. Then AI for weather and climate modeling, which is in partnership with MOES, Ministry of Earth Sciences, as part of and we'll be unlocking a lot of data coming from Mission Mausam and things like that. So we'll be doing a bunch of data unlocking work in the back end. AI for Bio and Life Sciences, again in partnership with DBT, and also Gates Foundation for the Life Sciences side of things. Okay, we'll be adding on many more partners. We are currently in conversation with many partners. The other interesting thing we are doing is, as part of our outreach, we are also having a contest track. So think of this as like mini challenges. So currently we are curating a whole bunch of challenges from industry sources or other things. And we are also making a requirement for whoever gets funding on my right track has to pose a challenge on the left track. So, so that we get an idea of, sort of a broader ecosystem of our universities, state universities and others who can, where the students, India's got talent in loads, they can all partner. We have the largest ecosystem. So open models can get developed. So we expect that contests and prizes and other things will be one model of working, and then the other model of working is a classic programs model of working. If we get some diamonds that we discover here, we will also fund them in our regular track. Partnering overall with MIT on GPUs as a service over here. And even though the goal here is to develop AI models and open data and so on, we admit of experiments, validation, or other things which where it's part of the scientific loop that you can think. So the goal here is not to fund a cryo-EM microscope that you buy with. You have a set of interesting things. You can accelerate. You can have some amount of your project that involves the experimentation work or validation work as well, in addition to the AI work and so on. It's not just a pure AI program. It's AI and science and engineering coming together. So overall, if you look at our combinatorial space of science and engineering, there is a journey of science, and many of these domains are getting incredibly complex to explore, right? Whether it's quantum simulations or material simulations or any other areas. So and even the exascale and other supercomputing facilities are not enough. Okay, so so while that continues, we'll be pushing the boundaries of that. What can AI do to help reimagine this future, right? So the potential for transformation is sort of shown in this picture, where different parts of the chain, there are different tools that are emerging, right? Foundation models and the techniques of foundation models can be applied in different ways. There is multimodal foundations that are there in general purpose AI can be applied. Now that's one. Second is specific areas. I mentioned about data acquisition, pre-processing. This is the traditional tools, but customized for science. Now beyond that, you can do based on representation and new techniques such as iterative refinement, candidate generation. How do you do predictions? Again, there is a whole bunch of ML libraries like SciML and others have emerged or have been sort of with the idea of AI model uses a aspects of physics or any other aspects of physics, engineering modeling of. If you're looking at processes, if you're a chemical engineer or a mechanical engineer, where you have PNID diagrams have been modeled using neurosymbolic techniques and so on. So there are different techniques which are appropriate for modeling various things. And then with that, you may have particular engineering specific scientific questions to ask in that loop of scientific questions to ask in that loop of science or loop of engineering. So then the techniques of reinforcement learning have been are starting to get used in other areas. Experiment design, what experiments to do, why should I do it, and how do I iterate between what I can do in the virtual domain and what should I do in the physical domain. So when I have a wind tunnel, I can be much more careful on what experiments I do, or dynamically optimize what I do based on a bunch of digital simulations that are going on in parallel as well, right? So then finally, once you have developed a product and put it out in the open, in the operations, I mean, we talk about this in Industry 4.0, now Industry 5.0, all these buzzwords, and now you can make it real with the underlying AI that is embedded, okay? So this is just a summarization of different classes of techniques. There is physics inspired or direct neural operators that have been modeled. So there's a whole class of these things. The idea of using generative modeling, such as using diffusion models or reinforcement learning, so that can help different things. So different tools help different things. Direct modeling of of equations and so on is more an operator modeling problem. Sort of optimization or search-based optimization, experiment design and so on is more of a reinforcement learning problem. Generative techniques are being used more in simulations of molecular simulations. And then now we are going to see HPC completely getting reimagined, where HPC and AI will start working with each other. So you have HPC runs that will give you validation data or sort of foundational data with which you train up AI surrogate simulations, do millions of AI simulations, and then you can revalidate them with other HPC runs, etc. Right? So what HPC runs you do will also be saying now, instead of HPC, if you want to then go to a wind tunnel and do a wind tunnel experiments, you can choose your technique of what you do. And also some of these things, for example, in the area of bio and so on, there is more robotic experimentation that is also emerging, where you can do high throughput experimentation, and robots and robotic experimentation help coming to explore the combinatorial space fast. Becoming interesting and complementary. And so it's important to understand which tool is useful for what, and then stitch them together as well appropriately. Okay, so this is the emerging areas that are coming through. So as you see, there are many topics using the fundamental idea of a transformer as a universal modeling tool. There are several techniques that have used Aurora, for example, is a climate modeling AI model that works 5,000, 10,000 times faster and gives interesting results, but they don't do very well in extreme event forecasting. They do things rather than trying to reinvent the wheel, even though it might be coming from other sources. So it's a trade-off between what you want to build ground up and have national sovereignty and things like that, but we can also host some of these models on sovereign platforms and fine-tune them. So we are going to try out all of these approaches. So whether many of the hyperscalers have been throwing out many of these models, whether it's by NVIDIA, they have some of these things, and BioNeMo and other things. But I would say that the area is still in its infancy, because even though there's a I would say that the area is still in its infancy, because even though there's a Cambrian explosion of many of these things, if you talk to the experts, everyone talk about how do I have much more stable protein and enzyme design and so on. There's still a ways to go, right? So how do you apply this and really move towards getting to the outcomes that we want? We are still far away. So there's tremendous approach possibilities for Nobel Prizes to be won, as well as huge impact to be had here. Okay, so let me just go through some of these things. The other aspect is, if you're in mathematics, clearly mathematical reasoning and reasoning techniques have become much more advanced, especially using various sorts of RL type technologies, reinforcement learning. And then when they are applied to a specific domain, as well as the ability to understand knowledge and understand patterns, if you think of mathematics as a pattern, formalization and sort of reasoning and so on. But at the same time, coming up with hypotheses that are outside learned distribution is an interesting open question. So similarly, but at the same time, large language models, of course, there's lots of debates about the limits of what large language models can do, what reasoning can do, and so on. But one thing is very clear: it can help accelerate a scientist who adopts large language models versus a scientist who does not. So the ability to have useful hypotheses, and so much more directed hypothesis generation and useful hypothesis generation rather than some junk hypothesis generation. These are all, again, techniques, how to do it systematically in various areas of science, various areas of engineering. I think these are, again, open problems as far as I know. Okay, so, but also the important thing is to understand at a deeper level what is the difference between the prior, there was AI before, there's AI now. The key difference them at much lower amounts of data requirements. What it means fundamentally is that you just need golden data sets. Small amount of very good data is highly valuable. So if you're sitting on cryo-EM data or other sorts of data, you're sitting on gold. Okay, so you better start doing interesting things with the data sets that is a small amount but very, very high quality, or diverse, or can help move discovery in new directions, right? So ANRF will hopefully catalyze some of these things, but I think you've got to wake up whenever I go around seeing instrumentation and I ask them hard drive, my heart burns. Okay, so you have to figure out how to use the data that you have in more interesting ways, and of course as a community how to share data better, so discovery and so on, right? So we are thinking about how we can help unify such fragmented data sets in more interesting ways going forward. Okay, so and also LLM as a knowledge amplifier, as a knowledge diffuser, the kinds of things that we are doing in Saral and so on are other useful things. Okay, so just to pick one area like microscopy and so on, today you take an instrument like a microscope, you get data. Okay, and then you do a lot of human processing, you do a lot of human preparation before and after, and so on, right? But suppose you apply AI, you can think of a whole bunch of orchestrator tools that can work along with any class of microscopy, like STEM microscopy, for example, and then you can orchestrate what you need to do at the microscope, what do you need to prepare prior to the microscope. Can I do robotic experiments so that a robot actually does the experiments and the human supervises them? And then beyond that, how do I understand what is the next experiment to do? So, if you look at the average life of a poor PhD student who gets, and it's a long access to microscopes, I know that we need to put more infrastructure out there, things like that, right? So, how do I iteratively decide what is the next experiment to do, what is the next useful experiment to do? All of these things, AI can be helpful, right? So, I think I just want to give you an idea of one specific domain which is probably closer to some of your hearts in this area, right? So, there are many areas. I'm just going to flash whatever area you're in. There is lots of open new tools that are coming out. So, there's an example in material science, again, diffusion models that can be used for faster material simulations, and then you can guide it as well, right? So, the idea of using diffusion modeling for target materials, molecular designs, or bio designs and so on is one area. So the other part of it is, if you just look at the process of engineering from a sketching to a final product, parametric modeling, doing design and high performance computing. Again, same thing, right? Design of experiments. It has a resonance with what you might do in science as well. So obviously, science and engineering have some commonalities, but the same thing you can accelerate. Now, the only thing is you're not doing science, but you're trying to build a car. You're trying to build a like an airfoil or whatever, right? So then, depending upon your domain, you can do different things, and the tools are different. But in general, the idea of having interesting high-value data sets and which AI can be trained on and can be used to manipulate, and then the appropriate AI models that can understand each area. And you don't need to integrate all these data sets. AI can independently get insights, and then you can have a macro AI model that can synthesize, or what is called insight fusion, across all of this, across these multiple modalities. Okay, so again, many things are happening, and of course, different tools. I just again a smattering of various tools. Various commercial companies are doing different things as well. There's a Toyota example where you can use generative modeling to come up with candidate designs, but with the constraints of how I expect a car to be, or how I expect particular aerodynamics to be, and so on. Right? So again, this is accelerating things. The other angle that is happening is hyper-customized designs. Today, it is very hard to come up with a single design for, because it just takes it's too costly. Once modeling becomes much more easier, and you can design faster, you can do more mass customization of designs as well. So this idea of a Birmingham blade, which means you can actually design wind turbines which are appropriate for particular geographies as well, right? So that's another concept that is coming out in AI as well, right? Okay, so again, we are working with the Ministry of Earth Sciences to unlock a whole bunch of their data that is available, and I was pleased to hear the Department of Space doing other things as well. And we have to get data out of their silos, and we have to use it together as a open community. So I would encourage various things, and of course, once you have, or even have partially this idea of different data sets coming together, you can have many more applications that can be done on so. But it will take a time for us to bring everything together. So, but there's no need to wait for it. Even as partial data set starts coming together, we can do interesting science, interesting things. So. Again, this is just for AI for science and engineering, the earth and climate modeling area. So there's lots of interesting work. This is just an example from my prior employer, Microsoft, which is an Aurora Foundation model that can help sample weather forecasting distributions and so on. Right? Then again, in drug discovery, I'm just going to flash through some of these things. But the important thing, as I want to mention, is the creation of gold standard data sets. There's already gold standard data sets emerging across the globe, but we need to create more gold standard data sets for Indian conditions, or whatever special context there is in India. And at the same time, we don't have to be parochial and say, oh, if some model is trained in the global thinking it will not apply to India. You're absolutely correct. It may not apply to India because some of the thing. But what is less understood is, there are common aspects between, say, a human in the other side of the world and a human over here. You have to focus more on the differences. And so what that means is you can fine-tune a model that is developed somewhere else with the appropriate data here, right? So that's a smarter approach rather than saying I'll have to completely reimagine and redevelop a model here. So the answers might be different based on if you want to do something for national security versus if you want to have a broader use case and so on, right? So we need more fair data sets, findable, accessible, interoperable, reproducible. So again, as part of our program, we support creation of such data sets. So if you're sitting on data and there's a need for some support to create and make this available for everyone, this program also supports that. So as part of the program, okay. So again, many of this can then further onward, enable many new areas, okay. So anyway, this is my last slide. Currently, what we are doing is in all of government, all of society, as I mentioned, we have partnerships with different departments, and this is going to be the style of ANRF. We are not going to do stuff alone just by ourselves. We will partner with multiple ministries for specific programs. That also expands the budget. More importantly, we are also trying to use that to smooth some of the frictions. Like if you want to get data sets from MOES, we'll try to simplify it as part of our program. Or in our MedTech program, we are working with ICMR to help some of the regulations or whatever the other regulatory assistance and so on, right? So in different departments, we'll be doing different things, right? But they're also partnering with non-governmental entities, whether from the funding side or from the industry side and so on. And we are trying to use two approaches: programs, contests, right? So this is a different style of supporting research, but our goal is that it has enough breadth, but it should have enough focus, right? Okay, that's all I have. Thank you. We need you. Okay. Okay. Yes, please. Go ahead. Yeah. There's some questions. Yeah, please go ahead. Yeah, short questions, please. I see many.